Okay.
We're live now, right?
Hey, ngHouston. So we're here at Improving. And we're really sorry that we're getting started late. We had some technical difficulties, but we're here and we have Minko, and I'm super excited about this talk. I really like Minko a lot. And then I saw his slide deck to see what he's actually going to be covering tonight, and it is super cool. So I'm excited, and we're late, so I'm going to go ahead and turn this over to Minko. So Minko, take it away.
Hey, hello everyone. Can you see my slides now? Thank you. So I guess you can see my screen? Yeah. Okay, cool. So yes, first of all, today we're going to talk about performance, runtime performance. So the most common topics recently were how we can make our bundle smaller, but in this presentation, we're going to focus on how we can make our application run faster. And yeah, a couple of words about me. Currently, actually, I'm a former member of the Angular mobile team. I've been working on a lot of tools, for instance, for static analysis, such as Coalizer. I've been working on Angular Seed and the Angular style guides. Currently, I'm working as I'm being a co-founder of a technical startup here in the Bay Area.
Can you guys hear? Okay, sorry, go ahead.
Okay. And here are some books that I have written. I wrote the book Switching to Angular 2, where I had the chance to work with Gechev, the creator of AngularJS and Angular. And the second edition of the book is Getting Started with Angular. So if you're getting started with Angular, this might be a good chance to do that. And so ngConf I presented this way, that like this compiler from Angular application, it generates a virtual reality where you can basically like literally walk inside of your application. You can see the components as trees. You can walk around and like do crazy stuff. You can even tree shake these trees. However, today we're going to focus on something much more practical. We're going to focus, as I mentioned, on runtime performance. So why it is important to focus on this? I guess all of you have seen a web app where you're just scrolling and you can feel how like sluggish, how laggy the experience actually is. So basically, the browser is rendering our application just like the video player is rendering the individual frames of a video that it is playing. And when we have very heavy computation inside of our JavaScript, the browser is going to start dropping frames. So it is going to start rendering the application slower, which is going to lead to very poor user experience. So our users are just going to see a not high quality application. But in order to understand how we can make our applications faster, we need to take care of optimizing the change detection in the framework that we're actually using. So in this section of the presentation, we're going to cover what change detection is, what different rendering and change detection strategies the individual frameworks are using, and we're going to dig deeper into the change detection mechanism used by Angular. So basically, the mechanism of change detection is a mechanism for detecting changes which should be reflected in the view, right? So when we modify a model, which we have been rendering onto the screen, we want to know when this model has changed in order to just update the view that we have rendered the model in. And there are a couple of main techniques for doing that. There is the observer pattern, which most of you, I guess, are already familiar with. Or if you're not, you can take a look at the best-selling book of the gang of 4 about design patterns. There is also the virtual DOM, which is kind of a change detection strategy, but it is on a slightly different level. We're going to discuss that. And we have the dirty checking mechanism, which was initially introduced into the JavaScript world by AngularJS. In order to put everything into a context and see how the change detection actually works, we're going to build yet another to-do application, to-do MVC application, where we have a text box where we can enter the individual to-do items. We have a button, which when we click, we're going to add the items to the to-do list. And we have the to-do list itself, where we have a checkbox in order to mark items as completed. So let's start with the observer pattern. The important thing about the observer pattern is that it is push-based. So when the model changes, it is going to push the update, and the update is going to be later handled by the view in order to reflect the changes into the view itself. So here is what is going to happen. Let's suppose that we have this pseudocode here, where we have a state which extends an abstraction called event emitter. And later, we are instantiating the state. We are mutating it somehow by pushing one to-do item. And right after that, we're emitting a change event. This change that you can see here, which is passed to the emit method, is just a constant. So it is just name of the event. We also have the view class, which we're just instantiating. And notice how we are subscribing to the change event of the state. So when the state changes, when the state updates somehow, we need to update the view itself again. So basically, the update method is just going to be something like looping over all to-do items, and after that, creating DOM elements and like rendering them on the screen. For instance, that's going to be the simplest possible implementation. So that's about the observer pattern. Now let's talk about virtual DOM, because that has been a very hot topic for the last couple of years. Basically, in the virtual DOM, we are always rendering the application based on the current state. So once the state changes, we're going to render the entire application, but instead of rendering it into the browser, we're going to render it in memory as a virtual component tree. So basically, these are a bunch of JavaScript objects which are rendered in the form of a tree, and that's it. The next time when the state changes, we're going to render this application again, and we're going to compare the previous virtual DOM with the current one. So the previous tree with the current one. We're going to find out the minimum set of differences and apply them to the view. So maybe it sounds a little bit abstract, but here is a specific example. We have the state here, which is just an empty array. You can see it onto the dark part of the slide. We have the component tree, which is into the middle, and we have the actual rendered application. When we push a new item into the state, what is going to happen is that we're going to render the entire application again in memory without touching the DOM. And we're going to compare the trees here. We're going to compare the top tree with the bottom tree. We're going to find out that there is only one difference between them. And this difference is that we have one more leaf node, which is child of the to-dos component. And right after that, we're just going to discard the old virtual DOM, the old tree, because we don't care about it anymore. What we're going to do after that is take the only difference that we have found and apply it to our user interface. So this way, we're going to render the buy milk to-do item inside of our to-do list. So that's what virtual DOM is. These are the three main strategies that are being used in the most, in the current modern web applications. And so, of course, we missed the last one, which is dirty checking. The dirty checking compared to the, yeah?
Can you stop for a second and see if that made sense? Did you guys see what he said about the difference between the first, the to-do, you had the first picture and the second picture? Did you understand? Did that make sense to you guys? All right.
It seems like that has the possibility of taking up a lot of memory, though.
Yeah, it can consume some memory, yeah. The virtual DOM. Well, usually the JavaScript objects, they are not that big in the end. They have in the range of between, let's say, less than 100 properties. So we're going to have on a typical application maybe a couple of hundreds objects with a couple of hundreds of properties each. So it's not extremely large. And we're maintaining only 2 trees at a given point.
All right, we're good? You're good. I'm good. OK, go. Sorry.
Okay, sure. No worries. All right, so the dirty checking, that's the pattern that we're going to make a deep dive in. And the interesting thing about it is that it is pool-based. So instead of the model, instead of the state notifying us when it has changed, we are going to ask the state when it has changed. So this is something similar to WebSockets versus polling with HTTP, for instance, if you have written some real-life, real-time services. So in WebSockets, for instance, we can get a push notification. However, with polling, we're constantly asking, is there an update for me? Is there an update for me? And so on and so forth. So the interesting thing is when the framework needs to check whether the state has changed, because that's the only way we can find this out, right? So when we're going to do that? Well, it turns out that we need to do it very often. Every time when we think that there might be an update when a call, like function invocation, might have caused side effects inside of our application. So this is after each event callback, after each network message. after each timeout callback or whatever. Here is how this looks in practice. So basically, when we send a fetch request, when we send an HTTP GET request to the network, and we get a response, eventually in the callback of the resolve callback of this promise here, we're going to mutate our state somehow. And right after that, we need to detect for changes. The same happens when we run a timeout. So after each timeout, after each the callback of each the timeout callback of the timeout function have been invoked, we need to detect for changes again. And the same for invoking event handlers. And the algorithm for detecting changes, it can be quite simple, something as a reference check, or something more advanced. It basically depends on the data structure which encapsulates our state. So if we are iterating, if our state is an array or something else, like a more complex data collection, we can loop over the collection and find out whether it differs to the previous state that we have. So this is the change detection which is implemented by AngularJS and also in Angular. However, in Angular it is much more advanced. We're going to talk about this a little bit later. But in AngularJS, you can go through the repository of the framework. You can see how this actually works, which is quite simple, by the way. And if you are scared of the huge amount of source code there, I can send you a link later where I implemented the dirty checking mechanism of AngularJS in about 200 lines of code, so you can see how exactly dirty checking works there. All right, so the good thing about AngularJS and Angular, specifically about Angular, is that we don't need to invoke the change detection manually at all. That's because Zone.js intercepts all the tasks and microtasks. So this means basically that Zone.js knows when a callback which might have caused a side effect have been invoked, and Zone.js knows when exactly to plug some custom piece of logic which is going to trigger the change detection mechanism. And basically, Zone.js does this by monkey patching the APIs. So here is how this monkey patching actually works. For instance, if we want to check for, run the change detection after an event handler have been invoked, here is what we can do. We can get node.prototype.addEventListener, and we can just replace its implementation with another implementation which calls the old handler of the event, and right after that plugs some custom logic. So basically here we're just monkey patching, just patching the addEventListener function of the node constructor function from the DOM. And here is how Angular does this. So this piece of code is just, it is directly taken from the Angular's code base, more specifically from the application ref implementation. So since Angular uses observables, here is an observable. We are subscribing to the onMicroTaskEmpty event, which is basically going to be triggered each time when a task completes or when the microtask queue is drained. So these are some, this is some terminology from the JavaScripts like event loop. If you're not familiar with it, you can just suppose that onMicroTaskEmpty is going to be invoked after all the different asynchronous events in our browser happening there. And once this callback have been triggered, once onMicroTaskEmpty just pushes a new item, we're going to invoke the method this.tick. And this.tick is going to perform the actual change detection. Here is the implementation of the method. As you can see, it's quite simple. We're just running a loop on top of all the different top-level rules, like top-level views in our application, and we're invoking their detect changes method. So that's the line of code that we're actually interested in right now. We're just looping over a collection of views and invoking their detect changes method. This might still not be completely clear, so let's take a look at this picture here. We have our component tree. We have our app component, we have the to-dos component, the input, the button, and let's suppose that we have one to-do item in the to-do list. So what is going to happen is that once the this.tick method gets invoked, we're going to invoke the method detect changes of the app component, which is the root component of our application. We're going to perform now DFS, like deferred search traversal of this component tree. After that, we're going to go to the children node of the app component. First, we're going to go to the to-dos component. We're going to check for changes there. After that, we're going to go to the to-do component, do the same there. Go to the input, like detect for changes there as well. And finally, we're going to detect for changes into the button component. Of course, if it is an Angular component or a directive. All right, and let me know if there is something unclear here. Is everything all good here?
Let me see. You guys have any questions so far? Anybody? No? Okay, keep going. We're good. Sorry, I turned the camera off so that because we were having a little bit of bandwidth issues. So.
Okay, I think that was the most complicated part of this, to see how the actual change detection mechanism works. So here is a simple application. You can see the template here. We have an input with ngModel where we have bound, where we have two-way data binding with the new to-do property of the component's controller. So basically, when the new to-do property changes, the input's value is going to change as well. And when the value of the input changes, the new to-do property of the controller of the component is going to change as well, right? So that's what ngModel does. And we also have ngFor, where we are iterating over all the different to-do items that we have. And for each item, we're creating a new to-do component, like new instance of the to-do component. And we're passing as an input the spell-checked version of the to-do. So the spell-checking algorithm, usually it can be implemented efficiently, or, well, it depends on the actual implementation. But the bad thing here is that it is going to be invoked quite often. So this banana in the box is because of the ngModel data binding. And let's see how many times we're going to trigger the change detection only by typing into the input field. So we're typing, and you can see into the console here, each message corresponds to one invocation of the spell check function, of the spell check method that we're invoking when we're passing the to-do item. So this is quite intensive. We're invoking the spell checking algorithm, and respectively, it is being invoked by the Angular's change detection mechanism extremely often. So if this spell check algorithm is heavy, obviously the JavaScript main thread, like the browser's main thread, is going to freeze, and we're going to start dropping frames. So we're going to create like very, very poor user experience.
I just want to ask, was there anybody else that was really relieved when he said that was the hard part and then switched to some code that we actually recognize? Was I the only one?
Yeah.
I was very relieved when you said that.
Yeah, basically, now we're going to take, in a little bit, we're going to take a look at some trees again, but that was pretty much it. And well, the bad thing is that we have only 16 milliseconds for our JavaScript to get executed. So, well, that's because if you divide 100 milliseconds to 60, because we need to have 60 frames per second in order to have very smooth experience of the user. We have only 16 milliseconds. Like, we have even less because the browser needs to do some internal stuff as well. And if our code takes more than these 16 milliseconds, the browser rendering is going to drop by half. So it is going to become 30 frames per second. After that, if we go like above 32 milliseconds, the browser will start rendering with 16 milliseconds, which is going to be like very poor experience. And that's a first practice from the performance checklist here. Do not add bindings to very heavy computation in the templates. Or like, yeah, that's the practice. You should be very careful about this. If you are adding such heavy computation, you should definitely know what you're doing. Otherwise, I would suggest you to, when you have such heavy computations, you can just cache the result out of them. And instead of performing these heavy computations that often, you can just provide the cached results. Now, let's go back to our tick implementation. So previously, we took a look at the top line after the try construct. Here, let's take a look at the views.forEach, and after that, invoking the checkNoChanges method for each view. Well, this checkNoChanges is for only one purpose. It is used for only debugging purpose and for Angular helping us to find out that we are doing something wrong. Let's take a look at this snippet. So we have a very simple component, a counter, where we have a template with a single binding to the counter property, to the counter getter of the counters controller. And each time when we get the value from the counter getter, we're going to increment the private property counter. So basically, we're never going to get a stable result, because the first time when the application renders, we're going to get 1, and after that, counter is going to get incremented. The next time, we're going to get 2, and counter is going to get incremented again. So we're never going to get a stable result. And that's actually why the checkNoChanges exists, in order to tell us while we're developing the application, well, sorry, but obviously you're doing something wrong. However, in production, we're most likely not going to write such code, or at least in development, Angular will have to tell us that we're doing something wrong, like we have some circular dependency or something between our bindings. So there is no point running the checkNoChanges in production applications. Well, that's the practice too. Always invoke enable production mode in our production applications. Because when we invoke enable production mode, like the exported function enable production mode, we are going to disable this check for circular bindings. And fortunately, this is the default behavior in Angular CLI, as well as Angular seeds and most starters. However, you should just double check that you're doing that, because otherwise, well, the runtime performance is going to suffer a lot.
Hey, Minko.
Yep.
When you do that checkNoChanges, how do you turn that on? Did I miss that? Did he show us that and I just didn't see it?
I know
production mode. Do you have time to show us how do you, if we want to use, is that there for us to use?
Well, the checkNoChanges is running by default. If you haven't invoked the enable production mode, this is going to be run by default, and Angular is going to warn you if there are circular dependencies between the bindings. So by default, you have this.
Okay, so if you're using Angular CLI, then enable to production mode and checkNoChanges is going to go by itself. You don't even have to do anything.
Yeah.
And then you.
Whatever you're using, you're going to have checkNoChanges. When you invoke enable production mode, checkNoChanges is not going to be invoked anymore. And
oh yeah, because it'll say that in the console log when you fire up a CLI app.
Yeah, exactly. And so the CLI, when you build your application with production flag in the CLI is going to invoke, it is going to place an invocation of enable production mode somewhere in the bootstrap file for your application. So this way, your production application is going to run much faster compared to your development one.
Cool.
Yeah. OK. So now we can take a look at how Angular updates its view. Well, basically, Angular is going to check for changes into the state, because it uses dirty checking. So it is going to check whether there are any updates into the state. And if Angular finds any updates, it is going to update only the pieces of the view which depend on this specific piece of the state. So Angular is doing that by generating source code. That's the innovative thing in Angular right now. Because what Angular is going to do is that it is going to just perform static analysis on top of our entire application. Angular is going to find out all the different bindings inside of our templates. And based on these bindings, Angular is going to perform a check whether the binding have changed. And if the binding have changed, Angular is just going to update the place into the view, into the DOM, which depends on the binding itself. So this is the most efficient way of reacting to changes, of updating the view based on change, because we're just performing the minimum set of operations. And Angular can generate this code, which performs this very efficient rendering for us, either runtime, or build time. If we're generating this code, this is called just-in-time compilation. If we're generating the code as part of our build process, we're calling it ahead-of-time compilation. This is very these two are very popular concepts from the area of compilers. There is the concept of just-in-time compilation and ahead-of-time compilation. And here is the difference between both. So there is, probably you're going to see that on your right-hand side, the application which is with blank screen for like 2-3 seconds. The application with the blank screen for 2-3 seconds is using just-in-time compilation. So when the user clicks onto the start button, Angular is going to take the entire application in the browser. It is going to find all the different bindings. It is after that going to generate source code which updates the specific piece of the view only when a binding associated to it has changed. And right after that, after Angular had generated this piece of code, Angular is going to invoke the eval function of the browser, which needs to after that like perform lexical syntax analysis of the code and invoke it. And after everything, like all this have passed, right after that, Angular can render our application onto the screen. So as you can see, this takes some time, and the user sees nothing else than just a blank screen. However, when we're using ahead-of-time compilation, things happen much faster. And why is that? Well, Angular have performed all these different phases of compilation and code generation as part of the build process. So when we have our application into the browser, we already have nothing else than just a bundle of code, which the browser have already parsed, and it is just ready to render whatever the next view is. So this practice says that we should always use ahead-of-time compilation for production. And actually, not only for production, but also for development, we are going to be able to use that pretty soon, because the Angular team is working for incremental compilation for the Angular compiler ngC, which is going to be applicable even for the development build of our app.
That's not available now, is it?
Yeah, I don't think it's available now. I think Tobias is working on this.
We had a
There's a bunch of like little modules and stuff that aren't necessarily compatible with the ahead-of-time compilation.
Yeah, that's a problem right now. There are some. Yeah, I can hear that pretty clearly. So there are some modules right now on npm which are not built with in a way compatible with the ahead-of-time compiler. That's because the ahead-of-time compiler needs some additional meta information in order to like build the application. And usually libraries are distributed with some meta files in JSON format. So not all of them, unfortunately, are distributed this way right now.
Hey, Minko, Rob wants to know what are the limitations of ES levels that we can use for ahead-of-time compilation?
Limitations of what?
What are the limitations of ES levels that we can use for AOT?
ES comes from ECMAScript?
I don't know, Rob. Well, we have a little bit of a delay. Huh? Well, we did this last time because he put V8 and I thought it was version 8, and Rob's like, no, Bonnie, that's not what I meant. So, Rob, you're going to have to clarify, but just give him a minute. Oh, ES5, ES6. So what are the limitations to ES6 levels? So, like if you're using ES6 TypeScript, what are the limitations for that on AOT?
Oh, yeah. Well, so first of all, we need to use TypeScript for sure in order to perform ahead-of-time compilation. And also there are some limitations. For instance, arrow functions in providers, they are not very AOT friendly. Where basically the rule of thumb is that when there is some very dynamic behavior which the Angular compiler cannot guess it ahead of time without running our application, this means that most likely it's not going to work. So that's actually the cool thing, that Angular is going to be available for development as well, because we are not going to have issues like our applications being properly run with just-in-time compilation, and after that failing to be compiled with ahead-of-time compilation. So yeah, dynamic constructs basically don't work that well. For instance, the arrow functions, they're specifically problematic because they just take as context the surrounding one. So there, this equals to the this in the surrounding code of the arrow function itself. And ahead of time, it's like it's not trivial to compute that and to be able to compile the application.
Okay.
So,
for example, if you turn on the turn off the no implicit any for TypeScript, and you have a library that hasn't defined a type for a variable instead of a function, you'll run just fine when you're doing the just-in-time compilation when you're developing, but if you try to run the build, it will fail compatibility issue. So it's just little things like that that are still kind of an issue when we're using ES5.
Can you hear her, Minko?
I heard most of it. Yeah, I think from what I heard, I agree.
An early adopter. If you're going to be like getting up there and breaking stuff, you should be a beta tester.
Yeah, problematic are definitely third-party libraries which are not distributed with type annotation, with type declarations and with metadata. So I had to dig a lot into the Angular compiler because of the tools that I'm working on, like ngReverse and ngST and Colorizer. So the code there it's very interesting, like very complicated. Basically, by reading it, you can see how you can build a compiler for yourself. And well, that's just a limitation there are just some limitations which cannot be overcome. That's because of the limitations of the actual languages and technologies. So I'm looking forward for the moment when NGC is going to perform incremental compilation in order to use it for both production and development. And of course, there is. Sorry?
Who's working on that, Tobias?
Yeah, I think that's. I think he's working on it right now.
We're all going to tweet Tobias and say, "When can be done, man?"
Also, Chuck is working on some great things with the compiler. For
who?
Like Chuck, he talked about the language service on ngConf.
Oh yeah.
He's really he has experience in compilers. He's really experienced in compilers. He have worked in Borland. After that, he have worked in Microsoft on some things related to like the JavaScript virtual machine there, Chakra. So yeah, he knows what he's doing.
We have another question. We have time?
Regarding the fat arrows, what you were saying, if you set your TypeScript to go to ES5, does that solve that? Does that help out the Angular compiler?
Oh, you mean if you want to compile so your source code to a specific target language? Well, basically.
No, I'm just if I set my TypeScript compiler to compile to ES5, then it should take out the fat arrow and go to a straight function, right?
Oh, I see what you mean.
Code problems for the Angular compiler.
Yeah, well, it's still going to be problematic because the Angular compiler is going to analyze your TypeScript code, not the output code which is produced out of a TypeScript compiler.
Okay, sorry.
Yeah.
I really like that arrow. I hate to give it up.
I know.
Well, you should not give it up like everywhere, only for provider declaration. That's because the Angular compiler needs some metadata out of the providers there. That's because, yeah, otherwise you can use it wherever you want to.
All right, thanks.
Minko, do you know if there's a blog post out there or anybody writing a blog post about, like, can we see that? Is there like somewhere that we can go? Is there a link where we can go and say, hey, if you're using the fat arrow, this is what you should know?
I think there is something like that. I think maybe I have written something, or Rango, I'm not sure.
You know you're doing cool stuff when you have to go back and look at a blog post that you wrote to figure it out.
I can take a look at it.
Now.
Recently, a blog post about, like, not very recently, maybe about a year ago now, about building an Angular library for production. Actually, distributing an Angular library. So maybe there is something like that. Yeah, probably. I'll send you a link afterwards.
Okay. Yeah. So if you look on Twitter, he'll tweet it. I'll retweet it, and we'll have that.
All right.
Okay.
So
Rob says that when you do it, which is one of the really good things about Angular, when they did that big overhaul on Angular, the error messages are so nice. So Rob has a good point that if you do it wrong, the error messages are pretty clear to tell you exactly where the problem is.
Mm-hmm.
So if you're using the fat arrows and you're running into problems, just open that console log, check the messages. Good point, Rob.
Yeah, it's constantly getting better. It's getting better and faster, and like it's really cool. All right, so should we go with the rest of the presentation?
Yes, we'll be
yeah.
quiet.
So obviously, the best way to optimize the change detection of the application is just to not perform it at all, and that's what I usually love to do. And we can do that with the change detection with the change detector ref. So that's one of the manual ways to do that. We're going to see other mechanisms for that a little bit later in the presentation. And with the change detector ref, what we can do is just to detach the change detector, which is going to not perform change detection for an entire component subtree, or we can perform change detection manually. And eventually later we can reattach the change detector, so Angular is going to work as expected. Here is an example which shows this. So we have a component which is just iterating on top of to-do items and rendering a to-do component for each to-do item. The interesting thing here is that we are injecting a reference to the change detector. And once we get this reference, we are just detaching it. So this means that when we push a new item to the list of items, we need to invoke the change detection mechanism manually here. And here is how this is going to look on our favorite tree diagrams, like tree images. We have our app component here. So yeah, let's suppose that we have the to-do application and someone is just typing something into the input. Or like a network event arrives or whatever. Just something triggers the change detection. So we're going to perform change detection into the app component. After that, we're going to perform change detection into the input of the application, and after that into the button. Notice how we skipped the entire component subtree with root to those components. However, if we push an item into the items of the to-dos component, we're going to invoke the change detection manually there, and we're going to perform it into the component subtree. We're going to find out that we have a new item, and we're going to render it. So this is extremely useful in a couple of cases. Imagine you have a real-time application where you're getting a lot of updates very often through a WebSocket. So for instance, you're getting push updates from the server every couple of milliseconds. So it's very impractical to run the change detection every time when you get a new message. You can, for instance, what we can do, for instance, is just to buffer all the different updates for a second and perform change detection at once. The same applies for WebRTC data channel or some other mechanism, or even very frequent events thrown by activity with the application from the user side. This way, we can implement a custom change detection logic, and this is applicable not only for very frequent updates, but like whatever other use cases we find. So we have this as an option. And this is practice 4. So we should consider running the change detection manually in case of very large state or very frequent updates. I'm saying here that we should consider doing that because it's not something that we should just start doing for fun, because this just changes the default behavior of the change detection mechanism of the framework. So it can get kind of weird. All right, so now we can stop on the externalizing the state. Well, we basically have almost the same component that we did have previously, with the difference that, well, we're still injecting the change detection ref. However, this time we also have a setter, which is an input. So basically, when we set the items property, the items input of the to-dos component, we're going to set the private property items, and we're going to invoke the change detection manually. We just externalized the state and moved it away from the to-dos component. So we're keeping it locally as well, but like the master component which knows about the state is somewhere else. This pattern is very often for Redux and Flux-like architecture, and like even in functional languages such as Elm or Haskell, we're just considering the entire component tree as a function, and we're passing the state from somewhere from the top component or wherever. However, there are two problems with this specific code that we saw. The variable that we're passing as an input, it can be mutated, it can be changed by another component. So here is an example. We have our parent component on top, and it has two child components, the to-dos component and a sibling component. When we pass the item with the array with to-do items to the to-dos component, well, the to-dos component is going to render it. Everything is good so far. However, when we pass the item, the to-dos array to the sibling component as well, and we push a new to-do item, well, the to-dos component is not going to be aware of the state change because we have detached the change detection there completely. So there is no way for the to-dos component to know that there is a new item into the list. And there is another issue that the snippet is not going to work at all, like because of several implementation details in the change detection mechanism. However, we can fix these, both of these problems very easily. All we can do is just to pass a copy of the to-dos item, of the to-dos array to the to-dos component. And that's it. This is going to fix the issue, because this way, actually, we're treating the list as an immutable data. We're not changing it. Every time when we try to mutate it, we're getting a new reference. And with immutability, if we suppose that we're always going to have immutable inputs, we can just drop this code here and add a custom change detection strategy. So with the change detection strategy on push, we can make everything work in a similar way that we already shown with the detaching of the change detection ref. So that's practice 5. Externalize the state and use onPush for skipping change detection for component subtrees. This here is extremely useful pattern, and I'm applying it super often for my Angular applications, and not only for Angular, but it has different alternatives for React, for instance. When you have immutable properties of your components, this practice can be extremely powerful. And it works really well with ngRx, for instance. And the last topic that we're going to talk about today, these are the pipes. Actually, that's something which you're probably using already, but it might be a good idea just to make sure that we know that we're using it and why. Well, I will have asked you how many of you are familiar with memoization, but it's going to be hard to verify. So basically, memoization, it is a technique which is used for speeding up functions. Basically, we can use memoization, not only functions, but source code, invocations in general. So what memoization does is basically some kind of caching. It can be implemented with caching. Let's suppose that we have a function for calculating the n, the factorial of some number n. We can pass 5 to this function, and the first time when we pass 5, we're going to calculate that the factorial of 5 is 120. We're going to return this result, and on top of that, we're also going to put it into a cache. So the next time when we pass 5 to this function, we're going to find the result from the cache, and we're going to return it. So that's pretty much it. That's how we can implement it. However, there is one very important detail. In order to apply memoization, we need to have pure functions, because these are functions which always return the same result when invoked with the same set of arguments, and they don't produce any side effects. Because imagine that we have an impure function which produces different results when invoked with the same set of arguments. In this case, it's not really applicable to use memoization because we don't know what result it is going to produce. And producing side effects, that's something we need to make sure that the function is not doing as well. Because if we directly return the cached result, this means that we're not going to produce the side effect which might be expected behavior. So we need to be aware of that. And the good thing is that we can consider the pipes of Angular as some kind of functions. So basically here we have a Fibonacci pipe. We just accept an argument of type number and returns the Fibonacci number corresponding to this argument. We have very naive implementation of Fibonacci here, but that's actually not the point. The point is that the pipe is going to produce, it is going to apply memoization by default to some extent. So Angular, when it sees that we're using pure true, and the inputs of given expression in our templates that we have binding to haven't changed, Angular will know that it doesn't need to evaluate the expression at all. Because if we have a pure function and we pass the same arguments to it, we obviously are not going to get a different result out of it. So Angular can just optimize the aberration of the different expressions that we have bound to. And the good thing is that the pure all pipes by default are pure. So we are kind of writing efficient code, maybe even without knowing that. And use pure pipes for faster expression aberration. That's practice 6. Also, there are some pipes which are impure by default. For instance, the async pipe, there is no way for it to be pure because it just needs to hold a state, like for the promise or the observable that we're using, that we have bound to. Yeah, boy.
Hey, Minko.
Yeah.
Sorry, I just wanted to pause for 1 second. Are you guys all familiar with pipes? Is there anybody who's not familiar with the term pipe? No? Okay, we have one in the back. You want to tell him, you want to explain to him what a pipe is, or you want me to?
Yeah, sure. Do we have experience with AngularJS?
Is it Angular or AngularJS? Oh, sorry, he doesn't want us to pay attention. Okay, so if I can.
I'm very new, so.
Okay, you know, on the DOM, you put the interpolation. You can do like an ng-for, ng-repeat, that kind of thing. Because when I started, I didn't know about pipes, but we called them filters back then. But
yeah.
basically, like you can have a little pipe that's like an uppercase or a lowercase or something like that, right? So if you want to apply a filter to something in the front end, you could take that out and make it into a pipe and then use that pipe. Like if you want to just capitalize the first letter of whatever you're doing, then you can just use that pipe all over the place. And it's a really neat tool, and I've used it a couple times. But when I first started with Angular, I didn't know what that was. So it was like the first year I didn't get to use the magic of filters because I didn't know. So I wanted to just make sure that everybody was on the same page with pipes because they're really handy.
Yeah, they're very good for separation of concerns. So if you have very like logic which is specific to formatting of data, for instance, pipes are extremely handy, like extremely useful. This logic for formatting of the data can be reused across the entire application.
It's typical for like formatting dates or a phone number or
Yeah.
stuff like that.
And Rob had a question too in the chat. Are there any other decorators that take pure : true?
I don't think there are any others.
All right.
Yeah, pipe should be the only one.
Okay.
What? Caching.
What's the caching?
Or is the first example cached or is that pre-cached or is that just a normal pipe? Because I'm familiar with AngularJS's pipe, but not Angular.
Can you put that slide back up, Minko,
Yeah.
launched a second ago? Sorry, I keep stopping you, but I just want to make sure everybody's, because there's like so much.
Yeah, so in here, does this include that caching that you were talking about, where if you give it 5 twice, it'll return whatever number it's supposed to be without going through the function all over again?
So what is going to happen is that this pure true is going to hint the Angular compiler that this pipe is pure, so the Angular compiler can generate more efficient source code.
Okay, nice.
Yeah, that's pretty cool. Yeah. So that was actually the last practice, and I wrote a list of such practices where I have more detailed description of these practices as well. So you can take a look at this link here, ng performance checklist. It has many more practices, and if you think that I have missed something, I would love to get a pull request and add your practice as well. And yeah, thank you very much. I would love to answer other questions that you might have.
Anybody else have more questions for Minko?
I do. So with the Zone.js, I've been looking online a lot, and I've noticed that it has a tendency to create infinite loops when it comes to the change detection. Are you familiar with that at all?
Sorry?
You said Zone.js can
So-
create infinite loops?
So the whole detection, all of that, and you get like maybe a getter in there, and you end up with like an NG model combined with a getter, and you end up with like infinite loops.
Have you experienced this particularly with ng upgrade?
With what?
With ng upgrade?
Not particularly, no.
Okay. Oh yeah. So and have you gotten this code by by Angular itself in development mode or?
No, no, yeah.
Oh, okay. Well, no, I haven't had issues with this.
I ended up just kind of a one-off, but I ran into it today, and I was looking online, and I found like half a dozen other people that had kind of run into that. So I guess
Okay.
be aware of like with all this change detection that Angular is doing, like the ability to run into this kind of implement.
Yeah, I'm not sure from what this could, because I need to take a look at the source code. If you have a snippet or you have seen an issue in the Angulars, like issue tracker, I'll love to take a look.
Yeah, sometimes. Or which version are you on? 4? Yeah, so sometimes if you're kind of pushing the newer versions, then you're gonna and reach out to me and ping me, because I know a lot of the people, and sometimes I know who to ask depending on what, because there's different people that work on specific things. And I'm happy to point you in the right direction, especially if there's any way that you can reproduce it. What do you call it? A plunker? It's so much easier, because then we can ping the right person, and if we don't know, we can ask them. And usually if you have a plunker and you could say, this is what it's doing, then and they like that feedback. I mean, as long as you're not like all hostile and angry and, hey, this doesn't work, this is crap, you know. But if you're like looking and asking questions, and you know, it's good to have that. It's just painful because you're on the cutting edge, but you know, it's cool though. Okay, do y'all have any other questions for Minko? And Minko, how much time do you have? Are you doing okay on time?
Yeah, I have like 30 more minutes.
Where are you,
So
by the way?
I'm in Bay Area.
You're in where?
In Bay Area.
Oh,
Yeah,
you're in the US.
Yeah, I live here for the last year or so.
Oh, I thought you were still in Europe. So I thought it was like the middle of the night. So you're
Oh, no.
cool.
It's all good.
So,
Yeah.
you're okay with time?
Yeah, it's perfect. It's 6
Okay.
It's 6 p.m. here.
So he's cool. We had Uri on talking about GraphQL, and it was like literally 4 a.m. He was, and Sani too. The same thing. Sani started live coding, like totally sleep deprived. It's like the middle of the night over there wherever he's from. He's live coding, and it was crazy. It was awesome though. Y'all have, so if you have a minute, because and remember what I said earlier, right? When I first met Minko, I was asking him questions that were like not even related to what he was talking about. I was just like, hey, you seem really smart. Do you know blah, blah, blah? So if you guys even want to ask questions that are not like related to performance, it's okay to do that.
I'm even using React. Like, I don't know how. Like,
You're using React?
Yeah.
They started talking about Vue. Everybody's talking about Vue. And I'm like, I feel like this is like it's like sports teams, you know? I actually got a hold of the guy that runs the React meetup here in Houston, and I was like, you know what? Just because there's so many blog articles out there about React versus Angular, and I was like, you know what? We should like get together, like your meetup group and my meetup group, and have like a smackdown, like WWF, like not like mean, but like a Family Feud type of thing where we like have a game show and and he was totally cool with it. He was like, yeah, it'll be fun. Let's do it. It was fun.
Yeah.
Okay, we do have some questions popping up in the chat. Burrell says, any .NET Core 2.0 Angular template experts? Not me. I'm not an expert on it. I never did. I was about to get into .NET, and then I discovered Angular and just kind of went off on a tangent and never looked back. So I'm not a .NET expert. You did the right thing. Yeah. Okay, so, well, it is getting kind of late here, so I think we're good. Oh, wait, hold on. Yeah, no, definitely.
Minko, you mentioned that if you take more than 16 milliseconds, you're going to drop to a 30 frames per second instead of a 60 frame per second rate.
Yeah.
When that happens.
Sorry?
How do you
detect programmatically when that happens?
Because your screen flickers. So what he was saying was that 16 seconds, was that based on your frame rate? That's how fast you need to be in order to not have a visible performance lag.
Yeah, 16 milliseconds. Yeah, that's when you have, so usually the browser can render the UI with 60 frames per second. So when you have 1000 milliseconds, which is 1 second, divided by 60, you're getting 66 milliseconds. So you have about, if you're running the code in the main UI thread, if you're running it in a web worker or service worker or anything, like you can take however time you want. Like it can take seconds, and you're not going to drop any frames.
And what he mentioned, which was good because I went through this at one point. There was an app that I was working on, and he's saying, how can you programmatically, like how can you measure that? And I think I think there's a better way now, but what I did when I had that question was like, we want to measure our performance, and we actually had a sprint where we focused on just performance, and like, but we want to see, like, we want to tell the big boss, you know, it was loading this and now it's loading this. Like, how do you do that? And what I did was I put a console log at the very beginning of like app.module, and then I put console logs, and it would like, and it's like performance.now or something like that would like tell you exactly how many seconds it's been. But now, what is it? Is there like a lighthouse or something? There are better ways to measure your performance.
Yeah, in Chrome DevTools there is a profiler which can tell you how much time exactly like each piece of code that you're invoking at given time has like takes. So it's there are a lot of tools in Chrome DevTools which are helping with that. Lighthouse is more for initial rendering and also how progressive your application is.
And I get a kick out of your story because, or your question, because true story, at one point when we first started, when I was first learning Angular, we were first trying to figure all this stuff out. We were kind of stumbling through it back in 2013. I literally was holding my iPhone on the stopwatch to see how long it took, and then I would hit the button to see how long it took this page to load. Like, I literally did that at work. Yeah, true story. So that's why I was like, that's actually a good question.
I would love to be able to say, for example, that
Huh?
if we ever go below 60 frames per second, how do we write an automation test or something similar to that, where I can say the automation runs all the pages in my app and tells me if I drop.
Yeah, it's also a little bit subjective because it also depends on the CPU of the device and the GPU of the device. So if you're running it in a like very low-end mobile device, the chances to drop below 60 frames per second are very high. Even if you're on your like Mac or PC, everything is going fine. So it's kind of, for this you can apply CPU throttling from Chrome DevTools. So you can basically reduce the power of your CPU with 50%. Like that's a feature in Chrome DevTools. So that's another thing which can be applied.
Or you can just get a big sticker that says it works on my machine.
Yeah, yeah, that's another option.
Okay, we had another really good question. Rob in the chat is not here in Houston, but he always joins us in the chat. He always has really good questions. Rob wants to know, what are the specific things that trigger change detection when using change detection strategy .onPush? Is it just properties decorated with input?
Yeah, when you pass, when you pass new references. So if with JavaScript you perform a reference check just like 3 times equals. Yeah, I just saw that something happened on the UI here.
Oh yeah, so, sorry, that was me.
Okay, so if you perform a reference check with like 3 times equals and the values don't match from the current inputs that like the component has compared to the one that you're passing right now, this means that usually onPush is going to be called. So basically when you pass new references to the inputs that given component has. And I've been using it with Immutable.js. I'm really happy with it. Like I built a quite big Angular application with Immutable.js and NGRX and a lot of onPush components.
Awesome. Awesome. Yeah.
What would you suggest using the async pipe, passing data into child components? Are there any catches, or is there a best strategy to use?
For the async pipe? I usually use the async pipe with RxJS if I'm waiting for an observable.
Yeah, RxJS for promises, yeah. And it works pretty well with onPush as well. Basically, if the observable pushes like a new reference, the change detection strategy onPush is going to like be triggered. With onPush, the change detection is going to be triggered, and everything is going to work just fine.
See, this is why I kept him in the hallway that day 30 minutes because like every day I asked him all these random questions and he just like knows all this stuff. And I'm like, well, let me ask you another question. Yeah. Poor Minko was standing out there with me for half an hour going, okay.
Like smart and dumb. Right, so what I learned recently is that so we call the smart components containers, the components. So you use your async type in your container, and to your components you just pass it a static variable. So it's supposed to use like async, or you just use it in your container and pass down static data. The dumb component.
Or what do you?
All right. I think, guys, that we're going to go ahead and wrap it up. It's getting kind of late. I want to remind everybody real quick about our announcements. We have some stuff that we're excited about. Next week, the Angular Masterclass is coming here to Houston, which I personally am really excited about because this has been like my pet project for a long time. So it's going to be here next week. If anybody's interested in that and has questions, just catch me after. Also, keep an eye out because we're super excited about Denny's Angular Upgrade Series. If you have any AngularJS code and you're trying to get it upgraded, then you're going to want to follow along with Denny's 5-part series, which is starting very soon, and it's going to be on Tuesday nights, and it's going to be live streamed. It's not going to be here in Improving. It's going to be online. So watch our Twitter, watch ngHouston Twitter for more news about that. And if you guys will give Minko a hand, because Minko, you're amazing, and this was so cool.
Thank you. Yeah, thank you very much for having me. Hopefully that was interesting and useful.
It was awesome. It was awesome. Thank you so much. And everybody, we'll see y'all next week. Minko, please come back and hang out with us again sometime because this was really fun.
Sure. Yeah, thank you for having me and have a nice evening.
Bye.
Thanks.
Bye-bye.